All right, folks, let's check our work on the test preparation that we had yesterday. Look, I see a lot of you guys doing exactly the right thing here, so I'm not really sure how much more I need to talk about the difference quotient. You know, I occasionally see some people not distribute the 2 or the -2 out here correctly, or they forget about the 2 in the middle. The middle term is double when you multiply these two terms right here together, like x times h, xh, and then you double that. That's how you get the middle term, 2xh, when you're squaring a binomial like this. So sometimes people forget that little 2 right there, but otherwise, I think you guys are doing pretty good. Check your answer there, and then I want you to check your answer on the other screen. Okay, so see if you got both of those, this one here and this one here. All right, ask me for some help if you're not getting those. Now let's look at number 6. This one's kind of interesting. When you do this work, we're doing g of f of x. So we're taking f, the f function, which is the square root function here, and we're putting it into the x's in the g function. I guess there's only one x in the g function. So we're replacing that x right there with the square root of x minus 3. Now, this little symbol, I don't know what's going on. I see that around. I think it has something to do with when we change from Microsoft, Word documents to Google Docs. That's my guess, is that these little extra X's show up. So try to ignore those. Anyways, when you put the square root function in for x here and you square it, the square root's going to, it's kind of inverse of the squared function, so they undo each other. And we've got x minus 3, and then you subtract another 1, right? So here's our function. We think, yeah, we got our answer. So let me show you what that looks like on Desmos. It's kind of interesting. So here is our g of f of x function. You could do this, when you're doing the final, put the f function in, put the g function in, and then do what they're telling you to do for the composite. Okay, now here's the weird part. I'm going to do the function that we thought we had, 1 over x minus 4. Okay, hey, I'm feeling pretty good about it. Like it lines up right on top, like over here. See how it's just covering up the green function, and it's covering up the green function down here. But you notice pretty quickly that there's this extra kind of piece to it, right? So what do we need to do? We need to restrict the domain from 3 on out to positive infinity. Now, where does that come from? Well, we're putting the square root of x minus 3 in for this x. So we can't have a negative underneath the square root sign. Like right back here, we can't have a negative right there. So that's why it's got to be all the x's greater than 3 or equal to 3. That's what they're saying right here. See, greater than or equal to 3. Now, what the heck's up with 4? Why are they skipping 4? See how they're not including 4 here, and then they take off from numbers that are just slightly larger than 4 from the right-hand side of 4 going out to infinity? Well, the reason why that is because our final answer, we can't have a 0 in the final answer. So you got to pay attention to both the f function's domain restriction and then your final g of f of x function. Kind of crazy here, huh? They're giving us a little extra credit for that domain, but man, that's really important to have. If you don't have that domain restriction, you got a bunch of stuff you don't want. All right, so I hope I'm making that clear. Would you check your answer on the other document? Okay, so what were we doing over here? We're doing some basic arithmetic. We're not doing a composite function on this one. I think I said this to everybody. You might not have a division. You might have addition, like g plus f. Right? What would that look like? It would be, this function plus that function. They have the same denominators. That'd be kind of an interesting one. You end up with, what, 5x plus 5 all over x minus 2? That would be if you had the addition going on. Let me see if I can write that with my mouse, because I don't really feel like getting out the pen tool. So if I had f plus g of x, right? Since they had the same denominator of x minus 2, I could just add their numerators together. So I get, what, 4x plus x is 5x. So we get a 5x, and then we have a 1 plus a 4 would be 5. That's a terrible x. Plus 5. I hope I'm making that clear. You might have to subtract them, right? It might be f minus g of x. It might be f times. What if you had f times g? They'll just stick them next to each other like that. You know, they won't have a circle. If it had a circle in the middle, then it's a following situation, right? But if it's f times g, they'll have them next to each other like that. Okay, well, we'd multiply these two fractions together. So, boy, I hope you're okay with all that. You might want to practice multiplying them together. You might want to practice adding, subtracting them. Could you look at the other document and see what they have us doing over here? Oh, look at, they have us doing an inverse, right? Switch the x and the y, and then solve for y. Now we did that. We did this inverse one on the first page. You know, well, if you call it page 1 and page 2, the last Friday's final exam, we had to do an inverse function. So I think we got that one taken care of. I don't think it's going to be an inverse again, you know, on this next page. So you don't have to worry too much about this one. But you do need to worry about the arithmetic one, right? So dividing the composite one, you might need to do that, right? But it's not going to be an inverse function. So check your answer there. All right, since we're on this page, let's scroll down here. How do you solve this logarithm? Well, you combine the logarithm using the properties. Then you set the little expressions equal to each other. So you solve it as a quadratic. You got to be careful because you can't have 0. 0 is extraneous solution, because if you stick 0 back here, you can't take 5 to a power and get 0, you know, or 5 to a power and get 0. No can do, right? So you always want to check these answers when you get them, and then don't include the one that doesn't count. Now, they factored it to solve. I saw some of you guys doing quadratic formula. That'll work too. It's a little bit of overkill, but, you know, factoring if you can see it. Down here on this one, same kind of principle. You know, you combine them using a property, and then you solve. All right? Guys, if you have any questions on this stuff, please, please, please ask me for some help, okay? Now, one thing before I shut this down, I was thinking, you know, why are both of these valid answers? Why isn't one of them an extraneous solution? It feels like that negative, we should cancel that out, but when you plug it back in, look what happens. Negative 2 plus 4, no, that's fine. You could raise 2 to the first power and get 2. And then negative 2 squared is positive 4. So we don't get any negatives in here, and we don't get any zeros if we plug in either one of these answers. So both answers are legitimate. They'll work. All right. Thanks for watching my video. Take care.